Hello everybody, welcome to another video lesson. Today we're going to go over ellipses and circles. After today we'll be able to analyze, graph, and identify equations of ellipses and circles. But first, before we get started, I want to recommend this book to you guys, a little book recommendation. It is called Genghis Khan and the Making of the Modern World. If you like history, if you're into that sort of stuff, this is a phenomenal book about Genghis Khan and the Mongol Empire, and it kind of shows a different light on these people who we thought were barbarians and torturous, murderous people. Okay, so with that, let's go ahead and get started into our concepts. All right, our concepts of ellipse and ellipse. Okay, hopefully you guys remember this term locus. Okay, a locus of points, where we are satisfying some geometric property, right? Okay, so this ellipse is a locus of points where we have the sum of distances from two fixed points that are called our foci. Okay, that sum of those distances is constant anywhere on the ellipse. Okay, so if this is my ellipse here, okay, we've got these 2 points here with the F there. Those are the foci. All right, and then I've got this point P1, and I've got these two distances D1 and D2. Okay, so now anywhere I move on my ellipse, okay, so say here P2, this point here, okay, are these two distances from the foci to this point are equal to the distances from the foci to P1. Okay, the sum of those distances is what we're looking at. Okay, so this is visually kind of what we're talking about here. So what that looks like in an equation is just that D1 plus D2 is equal to D3 plus D4. And that's going to be true anywhere I move along my ellipse. Okay. Okay, so the components of our ellipse, all right, go ahead and make sure you are writing this sketch down because this is what we're going to be talking about. These are the terms we're going to be talking about this whole video. Okay. We've got a major axis and a minor axis. Okay. We've got our vertex here. And the vertex runs along our major axis. And then we've got covertex, which is a bit of a different term for us, but those are the 2 points that run along the minor axis. Okay. Okay, and then again our two foci here, and you can see this D1 and D2 similar to what we had up here. Okay, and then you've got this A, B, and C, which again I will highlight on the next slide. Okay, but A is going to be the distance from the center to the vertex. Okay, from the center to the vertex is A. Okay, that's going to be the greatest value between A, B, and C. Okay, B is going to be the distance from the center to the covertex. Okay, and keep in mind A, since it's the greatest, is going to be, of course, greater than B. Okay, this distance is going to be greater than this distance here. All right. And then C is going to be the distance from the center to our foci. Okay, center to the foci, that is C. Okay, and I'll show you, you'll see what A, B, and C are in our equations in the next slide. Okay, going back to our other video, this is kind of what we're looking at in terms of our conics. Okay, if we have our double cones here, and we have our plane cutting these cones at a certain angle, that's when we get this ellipse. Okay, this oval shape, what you might think of is what we refer to as an ellipse. All right, and then if my plane is parallel to, say, the base of my cones, that's when we end up with a circle. Okay, so a circle is just a special kind of ellipse. All right, but we often refer to them differently. Okay. Okay, so let's go ahead and look at our ellipse standard form equations. Make sure you're writing down this whole slide here. Okay, I know it's a lot, and we have different, a little bit different like points here between our upright ellipse and our sideways ellipse. Okay, but it's important that we can quickly reference what we've got going on here. Okay, so keep in mind, I've got, if it is a sideways ellipse here, okay, what I have under my x minus h quantity squared term is a, okay, or a squared. Okay, and then if it's an upright ellipse, okay, my a squared moves to be the denominator of my y minus k term. Okay, we've kind of seen h minus k squared and y minus k squared. Okay, those again are going to be our points for our center. Okay, so our h and our k are our points for our center. And then we just use a, b, c, and k, or h and k, to come up with all of our points for our foci, vertices, covertices, major and minor axes. And then yeah, we have this relationship here for a, b, and c, where c is the square root of a squared minus b squared, or you can take a look at it before we simplify that and say c squared equals a squared minus b squared. Okay, so that's the relationship between a, b, and c. And again, what are a, b, and c? So c is the distance between the center and the foci. Okay, so center to the foci, that's our distance c. Okay, b is the distance from the center to the co-vertex to the center, that's b. And then a is the distance from the center to the vertex, all right? Center to the vertex. So think of our vertex again. If I were to say cut this ellipse in half right here, okay, what would be left with would look like a parabola, right? Look like a parabola, and the lowest point on that parabola is what we would refer to as our vertex, okay? So if I were to cut this on its minor axis, okay, then we have a sideways parabola, and again we would refer to this point V2 here as our vertex. Okay, so it's the same thing with our ellipse when we look at our vertex and our co-vertex. Okay? Okay, and then again, just noting that A is going to be greater than B, so that's how we can tell when we're looking at these equations if it's upright or if it is a sideways parabola. Okay, because our A, or our greater denominator, our A squared, is going to either be under the x quantity squared term or the y quantity squared term. Okay. Okay, now let's take a look at this other concept of eccentricity. Okay, eccentricity is just our ratio of c to a. Okay, so E equals c over a. Okay, that's just telling us how stretched or circular our ellipse is, and it's always going to be between 0 and 1. Always between 0 and 1. And if it is 0, okay, if E does equal to 0, then we have a circle here. Okay, we have a circle. And the only way for this equation to equal 0 is if C equals 0, right? Okay, so C would equal 0 in this instance, and our A and our B are equal to each other, and they're just the radius. Okay, so the distance from here to here is just r, as we know with the circle, but also from here to here, again, is just r, right? Just r, those are the same, okay, since that's a circle. All right, and then if it's in between 0 and 1, like we have here, then that's when we have this stretched ellipse. Okay, and then if it equals 1, okay, then it's kind of like we are breaking our ellipse or our circle. Okay, it's like we opened it so much that it breaks, and then now we have a parabola. Okay, so if you're working out eccentricity and you find that to be 1, okay, you know that you're working with a parabola instead of an ellipse or a circle now. Okay. Okay, last concept slide is just circles, which we've worked with a lot before, but in the context of these conic sections, all right, again, our A and our B are equal to each other. That's just the radius. Okay. So if this is our equation for, say, an ellipse with a center at 0, 0, okay, A and B are equal to each other, right? So I'm just going to substitute A squared for this B squared, okay? Then I can go ahead and multiply both sides by A squared. And let's see, we'll go ahead and since A and B again equal the radius here, I'm just going to substitute R squared for this A squared, okay? So now the standard form that we have for a circle, a standard form equation for a circle, is going to be this x minus h squared plus y minus k squared equals to r squared. Okay, so this is our standard form equation for a circle. Let's make sure we are writing this down as well. Okay. All right, let's go ahead and get into our examples here. First off, we're going to graph an ellipse given our equation here. Okay, so first thing we need to check is it in standard form? Yes, it is. Great, now we need to go ahead and find all these values. We got to find h, k, a, b, and c. Okay, those are going to be crucial for us graphing this. All right, so we know that we have x minus h here, and we have y minus k here, so we can easily say that h is 6 and k is -3. Okay, again, because this is h minus k, and this is y minus, or sorry, this is x minus h and y minus k here. Okay. Okay, so now let's see which one of these is greater, which denominator is greater. Well, that's this one, 16. What 16 actually represents is going to be a squared, right? Okay, so let's go ahead. If we're finding a, we're going to take the square root of 16, and that's going to give us 4. And we know since this is the lesser of our denominators, and this is representing b squared, we can take the square root of this and find that b is equal to 3. And we have our relationship for c equaling the square root of a squared minus b squared. And we can find that c is equal to the square root of 7. Okay. Now let's think about our orientation next. Okay. Again, I've got a squared, that's the denominator of my y term, and b squared is the denominator of my x term, right? Okay, so when this is the case, when a is the denominator, or a squared is the denominator of the y term, that's going to give us that vertical, that upright orientation. Okay, upright orientation. Okay, and then our center we know is hk, so that's going to be 6, -3. And then our foci, we've got h, and then for the y coordinate, that's going to be k plus or minus c. Okay, so we're going to leave it like this now for now. So we've got 6 and then -3 plus or minus the square root of 7. Okay, and then our vertices here, we've got h and then k plus or minus a. So that's going to give us, when I plug that in, I've got 6, 1 and 6, -7. And then our co-vertices, we have h plus or minus b and k. So we've got 9, -3 and 3, -3. And then our major and our minor axes. So we know that we have this vertical orientation. Okay, so our major axis is going to be x equals something, right? Because our major axis is going to be some vertical line, right? And any vertical line is x equals a constant. Okay, and then for our minor axes, we know it's going to be y equals something, because that's going to be a horizontal line, right? Okay, so I'm going to have, and I can just take x equals, and I can take my 6 from my center, because I know that both of these go through the center. So I can just use the center to find that the major axis is x equals 6, and the minor axis is y equals -3. Okay, so if I go ahead and plot those out, and I'll plot out my center, and then I can go ahead and plot out my vertices here. Okay, 6, -7, and 6, 1. Okay, and then I'll go ahead and plot out my co-vertices as well. Again, I'm just taking all these points that we have here, and taking our major minor axes, taking our center. We're just plotting these out now. And then I can go ahead and fill out my curve, okay, for my ellipse. Okay, now don't forget we can't forget our foci, okay, which we have right here. These are our points, right? So we just need to figure out what is approximately -3 plus square root of 7 and -3 minus square root of 7. Okay, so we've got those estimates right here, and we can go ahead and plot those out like so. Okay, so I've got my foci here and here. Okay. All right, we're going to move on to example 2, writing equations. Okay, so we're given certain characteristics for an ellipse, and we need to write the equation for that ellipse. All right. Okay, so for this first one, we're given a foci. We're given the 2 coordinates for the foci, for both foci, and we're given the length of the major axis. That's equal to 30. Okay. So now think about this. Okay, I've got the same y value, okay, for my foci coordinates. Okay, so that's going to tell me that we have this horizontal line, right? Because any horizontal line has the same y value all throughout. Okay, so that means what? Since my foci is going to fall on my major axis, that means I have a horizontal orientation, right? I'm going to have some horizontal orientation like that. My foci are here and here, say, along the axis. Okay, so that's kind of what we're looking at here. Okay, so now I know my k value, okay? when I'm looking at HK, since this is the center here, that's also going to have a K value, or a Y coordinate of K. Okay, that's going to just be 3, and I'm getting that again off of my foci coordinates. Okay, so now let's see. I've got this equation here. So I'm saying that 2c equals this distance between, hopefully you can understand, the distance between my two foci, right? So I've got 19 minus -7, and that's because here I'm at this, my x value here is 19, and here it's -7. Okay, and my C, or my center, is in the middle, right? So this is C, and this distance is C, right? So we can see if we add those up, we get 2C. Okay, so that total distance is 26. Okay, so my C then is going to be just half of that, right? So that's going to be 13. Okay, and then A is going to be half the length of our major axis. Okay, again, if I just think about drawing this out, A is the distance between the center and my vertex on each side. Okay, so if that is going to be 30, right, this whole distance is 30 from here to here, right, then half of that is going to be what A is, right? Okay, so half of that is going to be, if I erase that, half of 30 is 15, and I'm just going to go ahead and square that to give us 225, since we're going to need that for our equation eventually. Okay, our center is at the midpoint of our foci. All right, so I'm going to take the average of 17 and -7, or sorry, 19 and -7, and that's going to be the x value here. And I know that the y value is going to be 3 again. Okay, I'm getting that off of my foci coordinates. Okay, so I get 6, 3. Okay, and then to find b, we have our relationship between a, b, and c, and we can manipulate that to say b squared equals a squared minus c squared. Okay, and we find that b squared is equal to 56, right? So now we just have the general form equation here. We know it's a horizontal orientation, so we're going to have the a squared under the x term, right? And we can just go ahead and plug in all of our values, and that is what our equation should look like. Okay, so go ahead and pause the video now, and you try finding, with the vertices at these 2 points and a length of the minor axis equaling 10. Okay, try to figure out the equation for this second example on the right. Okay, here is what I have. You guys can go ahead and check your work. This is the equation that I have: x plus 2 quantity squared over 25 plus y minus 2 quantity squared over 36 is equal to 1. Okay. All right, moving on to example 3. Okay, we're asked to determine the eccentricity here. Okay, and we are given the equation. Okay, so given the equation, we know our eccentricity is going to be c over a. So I know that the greater of these two denominators is going to be my a squared. Okay, so I know that a is the square root of 19. Okay, and then let's see if we can go ahead and find our c, right? With this relationship here, c is equal to the square root of a squared minus b squared. Okay, I know my b squared is just my other denominator, right? So that's going to be 17. Okay, so it's going to be square root of 19 minus 17, or square root of 2. So our eccentricity is going to be square root of 2 over the square root of 19, or approximately 0.32. Okay? Not too bad there finding eccentricity. Let's go ahead and take a look at our last example of determining what type of conic we're looking at given non-standard form. Okay, so here we're given what we call generic form. Okay, so when we're given generic form, sometimes we're not really going to be able to tell exactly what type of conic we're looking at. Okay, so first thing we need to do is rewrite it in standard form. That's our first step. Okay, so what I'm doing here, I see that I have a y term that has a degree of 2, okay, and the greatest degree for my x is 1. All right, so I'm going to go ahead and get my x and my constant on one side, and I'll have my two y terms on the other side. Okay, but anytime we have for our standard forms, right, anytime we have a degree of 2, right, it's this perfect square. Okay, so what we need to do actually is complete the square on this left-hand side, right? So hopefully you remember how to do that. We're going to take our middle coefficient, halve it, and square it. Okay, and then we need to add that to both sides. Okay, so that's how we complete the square there. And then what we have left over on the left-hand side is going to be y plus 3, quantity squared, equals 3x minus 3. Okay, so I can go ahead and factor out the 3 on this right-hand side. Okay, and we can see here, if you remember from last video, that this is the equation, the standard form equation for a parabola. Okay, so go ahead and pause it again, pause the video, and take a look and try to do this second example on your own. Okay, hopefully you first rewrote it in standard form, okay, from general form to standard form, and then you got something like this for your equation and found that that was a circle, okay? All right, so that is it for today, you guys. A bit of a longer video, but that is ellipses and circles, okay? Good luck with your practice.